Hey everyone, it's Coding with Kareem, and today I want to make a video on mutex. A mutex is a mutually exclusive value or flag that is typically used in programming to protect a resource or a set of resources that can be accessed by multiple threads. So before we get too deep into that, I want to show an example of basic multi-threading. So in this file, we have a counter variable declared in global program space, and then we have an increment counter function that will iterate 10,000 times, and on each iteration, we're going to increment the counter variable by 1. In our main function, we're going to instantiate two threads, and we're going to pass in the increment counter function as an argument. So each one of these threads on instantiation is immediately going to start executing their argument functions. And then on line 17, 18, we're going to join both of these threads back into the main thread because we don't want the main thread to continue and possibly exit our program before the two threads finish their work. So looking at this code, we would expect the counter variable to be 20,000, right? Because both of these threads are going to increment 10,000 times and try to add one. Add one. So let's actually run this code and see what we get. So I'm going to compile, and I'm going to run the executable, and I get 11,000, 20,000, 16,000, 10,000. As you guys can see, of uh, we're getting a lot of random values. It's not consistent. Well, the reason why this is happening is because both of these threads are accessing the counter variable potentially at the same time, and because of that, we're hitting something called a race condition. So imagine the counter variable is 14. Both of these threads are going to knock on the counter variable and say, hey, this variable is 14. We need to add 1. 14 plus 1 equals 15. And then we need to write 15 back into the variable. So line 9, as you got, if you guys can imagine, is kind of 3 micro steps. So if two threads both read a value of 14 at the same time, they're going to do 14 plus 1 and then write 15 back into the variable twice. And you would expect the counter variable to be 16 if two threads accessed it at 14, but in reality, it becomes 15. So these threads are stepping on each other's toes. They're kind of sharing work. So to avoid this and to protect something that can be accessed by multiple threads, we introduce something called a mutex. We're gonna write a mutex in global program space, and inside the code where threads can access a value at the same time, we're actually going to call mutex lock, and then we're going to call unlock. So what is this code doing? So imagine one thread hits line 10 and says, hey, can we lock this mutex? Well, yes, we can. This mutex is available. It will lock the mutex. And then it will continue firing the code in line 11. If any other thread hits line 10, it will not be able to enter 911. Not 911, line 11. It will, okay. I'm not going to cut that out. The second thread will not be able to access line 11. It will have to wait for the first thread to call unlock. So this is a way to protect a shared resource when multiple threads can iterate on something at the same time and kind of mess it up. So now that we saw a very basic example of using a mutex, actually, let me actually recompile and run this code so you guys can kind of see this consolidated. So now we're expecting 20,000 each time, hopefully, right? 20,000, 20,000, 20,000. All right, cool. So moving on from, this basic example, I want to show something that's a little bit more practical. We typically do this on this channel. So I have this logger class. I'm sorry that you guys have seen this logger class so many times, but I honestly think it can be used as an example for so many different topics. And we are protecting this log file. In my opinion, a mutex is typically used for something that is kind of statically stored, kind of like a log file. Imagine you have a server somewhere that can have multiple threads firing and doing work, but even though you have multiple threads, you typically only have one instance of a file on that server. You don't want each thread creating its own instance of a log file. But if if all of these threads need to write to a log file, that needs to be done in a way so that they're not stepping in each other's code. So I'm actually only going to show you guys the example of removing this mutex from when we actually write to this log file, and let's see what we actually get. So I'm going to compile this code, and Great, I'm gonna call index, and then that should generate our log file. And then let's actually keep running this and let's see what we get. We should get some really random things. So as you guys can see, we're getting some really, really bad results. The reason why is because we have two threads in this file, doing work potentially at the same time. So we don't want that. That is bad behavior. If I were to reintroduce these the mutex, we wouldn't get that. We would get consistently task one started, task two started. We wouldn't get all these line breaks and things of that nature. Feel free to also clone this code and run it yourself, like I always recommend. So that's essentially the video. I hope you guys learned something. If you guys have any questions, please do let me know and I'll try to answer it. I'll also post all this code on GitHub and I'll try to add comments as well to make it a little bit more intuitive to understand. I hope you guys have a great life and goodbye.